Okay, so we just did data visualization, which is part of exploratory data analysis, and now we're going to do some summary statistics. That's the other part of exploratory data analysis. So when we do summary statistics for categorical variables, the main thing that we want to do is just count up how many things are in each category of our variable. So we would call that a frequency table. And sometimes we also want to know what percentage is in each one of the categories, and we'd call that a relative frequency table. So we're going to be using that formula notation that I talked about before, but we're going to use a new function called tally. And tally is another word for count, so that's why the function is called that. So the arguments of tally are almost the same as the arguments to GF bar. So I could do tally, parentheses, tilde, marital status, comma, data equals GSS. If I hit the play button on that, I get some output in my console, or you might get it right in your R Markdown document. And what this is telling me is that in the divorced category, we had 403 observations. In the married category, we had 998. And it's kind of wrapping around in a strange way. I can change that by making my console wider by dragging this line between my panes. And then I could rerun that code. So if I rerun it now, it's all in a nice line. It's easier for me to read. So what does this code tell us? It tells us the number of observations. And in my data set, the observations are people in a given category. So the most common category is married with 998 observations. There's another argument that we can add, which might make it a little bit more interesting. So we leave all the code the same, and then we just add format equal, in quotes, proportion. So I'll hit the play button here. And now what this is showing me is the proportion or the percentage of observations in each of those categories. And you can kind of tell because these numbers add up to 1. So I'll add 17% plus 42%, that's 59% plus 28%, etc. And I think it's going to add up nicely to 1. And so what does this code give us? It gives us the proportion or the percentage of observations in each category. The least common category is separated with 3.19%. So I'm just looking at this number and I'm multiplying it by 100 in my head, because again, this means 17%, so this means 3.19%. Okay, and then the last thing we need to do is look at the relationship between two categorical variables with a frequency table or a relative frequency table. So again, we can extend our tally code to two categorical variables by adding another variable into our code. In this case, we're going to make a true formula. So we're going to have a y tilde x. So we put one of our categorical variables here, a tilde in between, and another variable here. And we're going to try and look at the relationship between marital status and general happiness. I'm going to leave data equal GSS and format equal proportion. Click that play button, and now I get a big table of information, which has some conditional proportions. And I always kind of forget which way that they go, so the easiest way to figure it out is by just doing some mental math. So if I look across this column, I've got 25% plus about 20%, 45% plus another 10%, okay, 55%. That does not add up to 100%. So let's look down the column. I've got 25% plus about 20%, 45 plus 40, 85 plus 5, that's 90, plus 10, that's 100. Okay, so this is the 100%. And so that table is going to show me that of the people who say they're not too happy, 25% of them are divorced. Of the not too happy, 18% of them are married, etc. One thing is that it matters a lot which variable you put before the tilde. So if I switch the order of those variables, if I do general happiness, tilde, marital underscore status, and hit the play button, now I get a different kind of table. And again, I can just eyeball 20% plus 60% is 80%, plus 20%, 100%. Okay, so the percentages are going down the column. And this is saying that of the divorced people, 21% say they're not too happy, 60% say they're pretty happy, and 20% say they're very happy. So that's how you would interpret that table. And then the last thing is we might be interested in whether there's a relationship between these two variables. And we're going to learn some statistical ways to determine that later in the semester. But for right now, we just want to look at the table. And the way that we're going to look at the table is we're going to think about what if we had just found the tally of tilde general underscore happiness, comma, data equals GSS. And I'll also do format equals, in quotes, proportion. And hit enter. So this tells us that in the overall data set, not broken down by anything, 14% say they're not too happy, 56% say they're pretty happy, and about 30% say they're very happy. We've got some NAs in there too. So if there was no relationship between marital status and general happiness, we would expect to see 14% not too happy in each category, 56% pretty happy in each category, and 30% very happy in every category. Of course, it's real data, it's never going to be exact, so we just want to look at it and see, does it look kind of close to that or pretty different? So for the divorced category, 21% said that they're not too happy, 60% said that they're pretty happy, and 20% said that they're very happy. So those numbers seem kind of different to me. And what about married people? Well, 6% say they're not too happy, 51% say they're pretty happy, and 43% say very happy. Those look pretty different to me as well. It looks like we have more not too happy divorced people than we would expect, 20% versus 15%. And we have more very happy married people than we would expect, 43% versus 30%. So just kind of visually, I would guess that there's actually a relationship between general happiness and marital status in this data set. So that's the end of the pre-lab. If you wanted to, you could knit your document just to make sure that all of your code runs, and it should pop up in a pop-up window for you to look at. And it looks pretty nice to me. Mine seems to have all worked. And the code that we've done in this lab should be enough for you to do the real lab. So you could get started on that right now, or you could wait until our synchronous lab session together.